The North-South Freeway is the largest government road construction project since the government's relocation to Taiwan. It spans from Keelung in the north to Fengshan in the south, connecting with Taoyuan and Kaohsiung international airports, as well as Taichung and Kaohsiung Ports via branch lines. The total length is 373 kilometers, with 17 kilometers having 8 lanes, 18 kilometers with 6 lanes, and the rest having 4 lanes. The route design adheres to American highway standards. In the plains, the speed limit is set at 120 kilometers per hour, while in mountainous areas, the speed limit is reduced to 100 kilometers per hour. The maximum gradient in the plains is limited to 3%, whereas in mountainous regions, it is capped at 5%. The minimum curvature radius for the road is 600 meters. The North-South Freeway does not intersect with surface roads, eliminating the need for traffic light control and breaking away from the traditional road format in Taiwan. It includes over 10 interchanges, 10 toll booths, and an additional 6 rest areas, providing passengers with rest facilities, vehicle refueling, and maintenance services, which are unprecedented freeway features on Taiwanese freeways. RSEA Engineering Agency undertook the North-South Freeway project. It all began on May 18, 1971, when they participated in the international bidding process for this project. They successfully secured the 4th contract of the first phase project, which covered the Linkou to Nankin section, by submitting the lowest bid. In the same year, they also won the 2nd contract of the first phase project, which encompassed the Sanchong to Zhongli section, with the lowest bid. The smooth acquisition of these 2 international project contracts marked the starting point of RSEA's involvement in constructing freeways and instilled confidence in the government to entrust them with national road projects. As a result, they were actively awarded additional contracts for other freeway projects. This included the Keelung section, Taipei-Yangmei section, Yangmei Hsinchu section, Hsinchu-Tofan section, Tofan-Miaoli section, Tainan-Dongshan section, Jia-Yixining section, and Xining-Tainan section, totaling 29 contract projects. RSEA dedicated itself to the tasks of freeway construction, marking the commencement of construction efforts. This project involved the construction of a high-quality road that traversed both hilly terrain and plains. After numerous measurements by RSEA's engineering personnel, construction officially began in mid-August of the year 1971. Construction utilized 12-ton payload trucks along with state-of-the-art loaders and excavators, all of which maximized efficiency in this project. The volume of excavation and filling undertaken by RSEA totaled over 30.38 million cubic meters, which is 3.3 times the volume of the Zhengguen Reservoir. The excavation volume of earth and rock for the roadbed reached more than 19.27 million cubic meters, which is equivalent to more than 3 times the earthwork excavation of the Zhengguen Reservoir spillway, setting the highest record for earth and rock excavation and fill operations by the RSEA. The southern section of the freeway passes through the resource-rich Jinan Plain, with 18 million cubic meters of earthwork that must be transported to the construction site from nearby riverbeds. Therefore, some sections utilize the existing Taiwan Sugar Corporation's sugar trains for transportation. Compaction work on the roadbed is very important in terms of quality. For soil with high viscosity, spiky rollers are used for compaction. For sandy soil with low viscosity, vibrating road rollers are required. Some also use pneumatic tire rollers. The compaction density of each layer of soil must reach over 90% of the specified standard, and the top layer must achieve a density of 95%. The method for testing the density of the roadbed involves the use of the sand cone test, and occasionally, nuclear density gauges are also used. For areas with weak soil foundations, sand piles are driven to accelerate the consolidation of the soil layers to prevent subsidence of the foundation after the road is open to traffic. On the slopes near groundwater paths, permeable pipes are buried in advance to ensure good drainage for the roadbed in the future. During the construction of the entire road, difficulties have been encountered occasionally. In the northern regions, prolonged drizzle often increases the difficulty of the work. Before the onset of rain, covering with plastic tarps is a good method. The RSEA places extreme importance on quality control during the construction period, and the supervisory units also have very stringent requirements. For example, during the construction of the roadbed, the moisture content needs to meet a certain standard, and it is common to repeatedly turn and dry the sections of the road. The burial of culverts requires placing each section carefully in position before backfilling with soil and rocks. A small stone compactor is used for rolling compaction. After the slope was repaired, it was either planted with grass or protected using methods such as concrete mortar rockery, terracing, spraying, rock anchoring, etc., to protect the slope. To pour over 300,000 cubic meters of high-quality concrete, more than 10 automatic control mixing plants were established. A total of 349 bridges were built, among which 5 bridges are over 1,000 meters in length, with the longest being 2,345 meters. 2 of these are cantilevered pre-stressed box girders with spans exceeding 150 meters. The foundations of the bridges used caisson pre-stressed concrete piles or reversed circulation piles. All bridges utilized precast or cast-in-place pre-stressed beams. The precast beams were constructed using the Freycinet pre-stressing method, while the cast-in-place beams were pre-stressed using the BBRV method. Over 20 gravel plants were operational, with an average daily output of about 1,000 cubic meters per plant. The thickness of each layer on the roadbed is 20 centimeters, with a compaction requirement of 95%. The laying of hot mix asphalt amounted to over 872,000 cubic meters in total, which is the highest quantity for this type of project undertaken by the RSEA to date. More than 15 asphalt hot mix plants were established, each capable of mixing 120 tons of asphalt concrete per hour. To ensure a smooth and even road surface during construction, the base material is laid in 2 layers, first a 10 centimeters thickness, followed by a 6 centimeters layer. The compaction requirement for the road surface after rolling is 98%. The elevation difference within 3 meters is strictly limited to within 0.3 centimeters, which is very stringent. The RSEA used graders equipped with an automatic grade control system, which proved to be very effective. For the compaction of the asphalt surface, a 3-wheel roller was used for initial compaction, followed by final compaction with pneumatic tire and tandem rollers. An additional 1.5 centimeters thick layer of open-graded asphalt concrete was laid on the top layer of each section of the road surface to increase friction for vehicle tires during the rainy season, preventing the road from becoming too slippery. 2 paving machines were used side by side for paving, which was effective not only in saving time but also in reducing cold joints. The RSEA was responsible for nearly 170 kilometers of the North-South Freeway, which accounts for approximately 45.94% of the entire route. The construction was quite challenging and carried a significant responsibility. However, thanks to the high level of team spirit demonstrated by the employees of RSEA, this national construction project was completed by the end of August 1978, 4 months ahead of the scheduled completion date. The performance of the construction work was exceptionally good. After many years of hard work, the freeway was fully open to traffic on October 31, 1977. This was truly a day that brought joy and excitement to the entire nation. After the opening of the North-South Freeway, not only was the travel time between Keelung and Kaohsiung significantly reduced, but it also greatly increased the volume of passenger and freight transport. This contributed to the rapid economic growth of Taiwan. Shortly after the opening of the first freeway, it was operating at full capacity. The construction of the second North-South Freeway, East-West Freeway, expressways, and the freeway networks including the Bay and Shuishan Tunnel freeways, were subsequently actively initiated. The RSEA continued the excellent performance of the first freeway and kept undertaking tasks assigned by the government. While undertaking domestic freeway projects, The RSEA also actively engaged in overseas road construction projects and completed many international-level highways. The professional engineering skills of RSEA's personnel, their enthusiastic work attitude, and the excellent quality of construction have made the RSEA renowned in the highway engineering field, gaining international acclaim. The spirit of the RSEA, shining brightly with the sun and the moon, has laid a solid foundation for our country's international diplomacy.